Hello, and welcome to Nyx-IT's Info Post. In today's video, we're going to be covering the benefits of cloud computing. To give you an overview of the topics that we'll be covering in this subject, it's going to be the total cost of ownership for computing infrastructure, the two types of computing expenditure, the computing evolution, on-premise, also known as dedicated infrastructure, virtual machines, containers, and functions. In the first topic, we're going to talk about total cost of ownership, CapEx versus OpEx. CapEx being on-premise ICT costs, OpEx being cloud environment costs. To make this easier to understand, I've used an iceberg representation to give us a visual representation of the kind of costs that really go into CapEx versus OpEx. So for CapEx, the first obvious cost would be your licensing fees, but hidden underneath the waters is your implementation cost, your configuration cost, training cost, and even deeper than that, you can go into less obvious costs like physical security, hardware cost, IT personnel, maintenance, and upgrades. Now, when you look at the costs of operational expenditure, the first obvious one would be your subscription fees. Next, you would look at the same costs of implementation, configuration, and training, but all the other costs of things like hiring security personnel, the hardware cost, hiring of IT personnel, maintenance and upgrades are covered by the cloud service provider. Everything else becomes the cloud service provider's responsibility. When OpEx is implemented correctly, this could lead to up to 75% savings of the total cost of your computing power for your business. So now we're going to take a deeper look at CapEx, or capital expenditure. CapEx is spending money on infrastructure ahead of having your applications running on them. So this means you can't accurately determine the computing resources required to run the applications, and usually you overestimate on the budget required for this infrastructure. So the costs of capital expenditure can include server costs, which is your computers, storage costs, which is your hard drives, network costs, which is routers, cables, switches, access points, facility costs, which is your power, the rent, cooling, physical security, disaster recovery costs, backup costs, and archive costs, and technical personnel costs, or IT staff that you need to employ. In the next segment, we're going to look at operational expenditure, otherwise known as OpEx. Cloud services run on an OpEx cost model, where you only pay for the non-physical expenses of running your applications. There is no need to invest in any equipment. So the cost for OpEx that will include leasing software and customizing features, training employees in cloud services, paying for cloud support, itemized billing on usage metrics, computing power, and storage space. Next, we're going to talk about the computing evolution. So this is pretty much how computers go from on-prem to virtual machines, to containers, and then to functions. A similar shift happened in the way businesses used power back in the late 1800s. Back then, most factories had their own generators to produce their own electricity and power. This then shifted to companies like the Edison Power Company, who could then generate and distribute larger amounts of power to factories as a service, which in turn drastically reduced the operational costs on-site for the factories, as well as keep the factories powered for longer. The same thing is happening for how we use computers to process information and run applications for our businesses today. And this is called cloud computing. For the next segment, we're going to focus on on-premise or dedicated servers. So this is the traditional way that we know servers and computers in business today. It requires physical space to be implemented, and depending on the size, could use a lot of resources, especially capital resources. The capacity requirements are usually overestimated and underutilized, making the physical hardware more expensive than what it actually needs to be. It is quite limited by the operating system that you run on it, and upgrading it beyond its physical capacity will be a slow and expensive process. I've added some visual representations of exactly what a physical machine would look like on-premise today. So if you look at the visual representation, there's the host operating system, the applications running on them, and a lot of wasted space that you've paid for but you're not utilizing on them. For the next segment, we're going to talk about virtual machines. Virtual machines are computers simulated on another computer, almost like computeception. These virtual machines are powered by software called hypervisors, which partition part of the physical machine's components to be used for the virtual machine. The physical server is shared by multiple customers, making the overall cost of running a virtual machine a fraction of what an on-premise server would cost you. For the visual representation on this slide, you can see that the physical machine runs a host operating system, which then runs the hypervisor, which then runs the virtual machines, and in part that runs their guest operating systems and the applications on those virtual machines. There is still some wasted space based on the size of the server that you select, but overall it's a lot less than on-premise. In the next segment, we're going to talk about containers. Within a virtual machine, you can run software called Docker daemon, which lets you run multiple containers. This allows you to maximize on the available space in a virtual machine and allows you to run multiple applications at the same time. One of the biggest benefits of running a container is that you're able to run multiple operating systems within them, making it more flexible than a standalone virtual machine. You can maximize on utilizing the available capacity in each virtual machine, which makes it extremely cost-effective. You'll see there's a visual representation of a physical machine with a host operating system on it, running a hypervisor with virtual machines on it. And these virtual machines then have guest operating systems with Docker daemon loaded onto them and applications running on the Docker or the containers. In the next segment, we're going to talk about functions. So with functions, we can even take it a step further by breaking off the applications into code called functions, which runs on managed virtual machines running managed containers. This is also known as serverless compute. You upload a piece of code, choose the amount of memory you need for that function and the duration you want to run it, and it just works. You're only responsible for the code and the data, nothing else. This is a very cost-effective way of doing application processes because you will only pay for the runtime of the code. For the visual representation, you'll see there's a physical machine, a host operating system, hypervisors running virtual machines, and then with guest operating systems and Docker loaded onto the virtual machines, and then these virtual machines just run functions, or pretty much the segments of code that you would want to run for the application. And finally, I just want to thank everyone for watching until the end. And I also want to credit Andrew Brown from Exam Pro for pretty much descripting the ideas within this presentation. I'll leave a link in the description below for the original video where I found these ideas.